So we are going to do an example here of polynomial long division. So we know that if we have some rational function here, right, so this is our rational function, p is a polynomial, and q is a polynomial, right, so we have a ratio of polynomials, then it's called improper if the degree of the numerator is greater than the degree of the denominator. And in this case, right, so if f of x is improper, then we can perform long division and write this here, right? This p f of x is equal to s of x plus r of x over q of x. So what that means is, you know, s of x is a polynomial and r over q is a proper rational function. So we're able to take this improper rational function and write it as the sum of a polynomial and a proper rational. And this will make integration much easier. Right, so let's just do an example of an improper rational function, writing it as the sum of a polynomial and a proper rational function by doing long division. So let's take this example here. Then, you know, this is an improper because the degree of, you know, if we write this as p over q, right, degree of p is 3, right? And the degree of q is 1, and you can't see it here because it's just a, you know, the leading term is just 2x. We don't write power 1, right? But that's what we have. And so, you know, degree p is greater than degree q, so this is improper. Right, so now what we, you know, call, maybe you called in your algebra classes, the numerator here is the, in the case of long division, right, the numerator here is our dividend that goes under the radical. And then the denominator, right, is the divisor, right? So that goes over here. Okay. Okay. So now we do this long division just like regular long division. So I mean, in a similar way, right? So you can kind of think of like these different powers of x as like the hundredths place, the tens place, right? Thousands place, and some large integer if you're doing integer division. So what we do is we start here looking at the leading term of the divisor and the leading term of the dividend, and we ask how many times, or how many times does 2x go into 2x cubed, right? So 2x times x squared gives you 2x cubed, right? So it goes in x squared times, right? Another way you could, you know, do this is just say, well, 2x cubed divided by 2x gives you x squared, so it goes in x squared times, right? So it's x squared, right? So we have, this goes in x squared times, and we put that up on top of the radical sign, and we like to keep everything in the right place, and so we can just put this x squared term over the square term in the dividend. So now we take our x squared and we multiply it through the divisor, and you get 2x cubed plus 1 times x squared gives you just an x squared, right? So you're distributing this, you know, all the way through. And then we subtract this new line from the dividend. Okay. And this leading term that you get should always cancel out if you did that correctly, right? And then when we subtract the whole thing, we're subtracting this x squared from 3x squared. We get 2x squared, and these other two terms just come down, right? And then we're going to repeat this whole cycle again. We treat this new line, 2x squared plus 7x plus 4, as our new dividend, right? So we look at the first leading term of the divisor and the leading term of the dividend and say, how many times does 2x go into 2x squared? Okay, so again, we have, 2x times x gives you 2x squared. Right, so that should be x, and the other way to do that is to say, well, 2x squared divided by 2x gives you x. Right, that's supposed to be an x there. Right, so we have our x, right? And that goes up top, and to be nice and neat, we keep it above the power 1 column. Oops. Right, so plus x, right? And then we take this new term here that's in the quotient, and we multiply straight through our divisor, right? And we get a 2x times x gives you 2x squared, as it should. And then distributing this, right, we distribute it. So 1 times x just gives you x, right? And then we subtract this whole thing, and we take 2x squared from 2x squared, gives you 0. 7x minus x gives you 6x, and then this 4 comes down, right? So we repeat this process as long as what remains, so this new line here is what remains, right? As long as what remains has degree greater than or equal to the degree of the divisor. So the degree here is 1, right? Again, it's that like invisible power 1, right? And then when we get to the point that what remains is of a lesser power or lesser degree, then we're done. So we still have more work to do here, right? Because we have that 6x plus 4 has degree 1, and 2x plus 1, our divisor has power 1. So we look at the highest power term, or the leading term here. Stick with our color scheme here. And here, right? So how many times does 2x go into 6x? I'm gonna make this zoom out a little bit so I can move. Right, so this goes in what we say 2x times 3 gives you 6x, right? So that should be our 3 here. But we could also say, well, 6x divided by 2x is 3, right? So it's 3. That's what's going to go above the line, and we like to keep it in the right column there. So plus 3 here. It's a little bit messy, right? And so now we take our 3 and we multiply it through our divisor. 3 times 2x gives you 6x, as it should. And 3 times 1 gives you 3. Right? So then we subtract this out. We get that the 6x's cancel. 4 minus 3 gives you 1. Now the degree of a constant is just 0, so the degree of 1 is less than the degree of 2x plus 1, right? So we're done with long division. And we call this last thing that remains the remainder, right? So this is our remainder here. And now we can write our, you know, our f of x in this form here, right? So we have the polynomial s of x up here corresponds to this, what we call the quotient, right? Which is this thing here, right? So our remainder corresponds to this r of x that I circled in red here, right? Q of x is our divisor. So we have that, summing this up, we have that, maybe I'll go down here, that f of x is equal to this x squared plus x plus 3, right? That's our quotient. Plus our remainder, which we have here is 1, over the divisor here, right? So over 2x plus 1. Right. So this is our quotient, right? This is our remainder on top, and this here is the divisor. Right, so in general, you know, when we have long division, right, we have this thing here is the dividend, right? This is the divisor. This is the quotient. And when we do our you know, computation here, we eventually get to, you know, this remainder. And the remainder is whatever's left over when the degree of whatever's left over is less than the degree of the divisor, right? And then you have, right, that this you know, dividend over divisor is equal to the quotient plus the remainder over divisor. I'm not sure why I decided to capitalize some of those words and not others, but that's what we have, right? So it's just kind of generally, right? Okay, so then, you know, why do we do this? Well, this does make it, at least in this case, does make it a lot easier to actually compute this integral, right? So we started with this, we started with 2x cubed plus 3x squared plus 7x plus 4 over 2x plus 1. And we got from long division that this is the same as x squared plus x plus 3 plus 1 over 2x plus 1, right? And so when we, you know, integrate, this will become pretty simple, right? So before doing long division, I don't know of any method that we would have covered, or you would have covered in Calc 1, that would have allowed us to compute this directly on the left side. But over here, this is just the integral of a polynomial, which should be, you know, one of the easiest things to integrate, right? Plus the integral of 1 over 2x plus 1, right? So we'll deal with that in a second. right? So here, the polynomial, when we integrate, we're just using the power rule. That's really nice, easy integral there, right? And over here, that's almost, you know, as easy, but maybe we just have to do a little bit work to simplify it first by doing a u sub, right? So let u equal 2x plus 1, then du will be equal to 2 dx, right? So dx will be du over 2, right? And this will become this whole thing copied down, right? Plus the integral du over 2u, right? Which we could pull out this 1/2 here. It's just du over u. And that is just the natural log u. Right, and we'll add a constant of integration. So we get this integral is this x cubed over 3 plus x squared over 2 plus 3x plus the 1/2 ln of 2x plus 1 plus c. Okay. This is an absolute value sign here.